Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic that is types of functions, guys. So in this lecture, we'll be going through the first type of functions that is a one-to-one functions, guys. Okay, so one-to-one functions are nothing but they are going to map one to one. So basically, the other name of this one-to-one is injective, guys. So once we go through the example, I will be giving you a small trick to remember the names, guys. Okay, so don't worry. Okay. And mostly I'll be covering the three types in this lecture only, guys. Initially I thought I'm going to divide them into three different lectures, but I thought there will be around 2 to 3 minutes only each lecture, so it will be really short. So I'll be combining them 3 into 1. Okay, so what does a one-to-one say exactly is if there are two sets, okay, if each and every element of this set 1 are mapped to one element of set 2, at that time we call it as one-to-one. That's it. There could be extra elements in set B, but all the elements of set A should be mapped to at least one of the other. At least one means only one, to be clear. Sorry, not at least also. More than one will not work. Only one, that's it. Okay, and they should be unique also. Okay, so if you observe here, this one is matched to A, good. 2 is matched to B, good. 3 is matched to D, good. Everyone is done. Here one is left. So what? Why should I care? I'm taking care only about X. So with that conclusion, you can say that this is a one-to-one function. Similarly, moving on to the second example, here everyone is mapped equally. So here there are 4 elements, here there are 4 elements. So here there is no issue. Okay. When it comes to the third example, here there are 3 elements and here there are 2 elements. Means 1 is mapped to A and 3 is mapped to B. But here 2 is left out solo. When it comes to 1 to 1, 1 to 1. So everyone should be mapped from 1 to 1. That's it. So from reverse we don't care. Only forward you need to be 1 to 1. That's it. Got it? Yes. So with that understanding, you can say that this is not a one-to-one function. Okay. To be clear, few students will be like, okay, we want some formulas. We want some formulas, right? Yes. So to be clear, the number of elements in X should be less than or equal to Y. That's it. Because if they are greater than Y, it will end up with a wrong answer, right? Yes. Okay, so now let us go to the definition and let me explain you the word injunction. So basically injunction. So what is that similar word, guys? It is injection, right? Injection. A similar word, okay? Just for remembering I am saying, guys, okay? Yes. So it is somewhat similar to injection, okay? Yes. So what is the concept of injection, guys? So if a particular injection is there, it will be given for only a single person, right? Or it could be given for multiple persons. So basically one-to-one is also in the same way. So basically if you are an injection, you will be given to only a single element. You cannot be given to 2 elements because of blood issues and many other issues, right? Yes. And that injection should be used in time only. So that is the reason why if there is any left out injection, that will be also an issue. Got it? Yes. So that's how I remember, guys. Okay. So it might be easy for few and it might be good. Like you might have some other tricks. Okay. Yes. Okay. So an injective function, also known as injection or one-to-one function, is a function that maps distinct elements of its domain to distinct elements of its codomain. Okay, so every element of the function codomain is the image at most one element of its domain. Okay, so one more important thing is, so in examination the concept which they ask is the number of functions possible, guys. So I think there are almost 3 to 4 problems on all the types of functions, guys. From each and every function, at least once they gave a question, like direct formula based. That's it. If you know the formula, you will solve it. That's it. No more words, nothing. Okay. Yes. So the way how you can solve is, so they will ask a number of functions possible if the value of m is a 3 and n is a 5. Okay. So recall one thing, guys. So basically what they are saying, the value of m equal to 3 and the value of n equal to 5. So they are saying here there are 5 elements and here there are 3 elements. 1, 2, 3. A, B, C, D and E. So first of all, the first step which you should remember is, so how many options does this first element have, guys? So he could be connected to A or B or C or D, anyone it could connect. So there are total 5 options with A, right? With 1, right? Yes. When it comes to 2, so 2 cannot be connected to the one which is connected to 1, right? So assume that 1 has been connected to A. At that time, 2 is left out with the B, C, D, E. So basically it is left out with 4. Similarly, this is left out with 3. So in total, if there are 3 and 5 elements, like m equal to 3 and n equal to 5, the total possible functions will be 5 into 4 into 3. That is nothing but, okay, 5 4s are 20 and 60. So the result is a 60, right? Yes. Or am I doing any mistake? Yes, it is 60. Okay. Yes. Okay, so 60. So in this way you are going to solve. But few students will be like, okay, so in this case you are able to solve it directly. But what if the question is given like 10 in M and 20 in N? Will you solve it in this way? That is not an ideal method. Most of you will be like that, right? Yes. So that is the reason why there is a small formula for this, guys. So it is a nothing but permutations, guys. What we are doing exactly? There are only 3 items or 3 bags in which you can place only one item among 5. So it is nothing but permutations, right? So it is a nothing but npm. That is a nothing but n factorial by n minus m whole factorial, right? Yes. Okay, so that is the formula which you can directly apply to get the answer. That's it. Okay. Yes. So that's what is written in the book also. You can just follow any one of them. Okay. Yes. Okay. So now I hope everyone got a clear idea about one-to-one, right? Yes. So what shall I do, guys? Shall I break the video here or shall I continue? So I think continuation will be better, guys, because these videos will be taking around 1 to 2 minutes. That's it, right? Yes. Okay, so let us continue. So the next topic is on-to function, guys, or surjunction. So basically this is the second type of function, on-to. The first one is 1-1 and this is on-to. Okay. Yes. So what does on-to function says is it is also called as a surjunction. Okay. So what does onto says is it is quite opposite of 1-1, guys. So in 1-1, what is the thing? It is 1-1 from this side, right? When it comes to onto, it is a 1-1 from this side. So basically from codomain to domain. Got it? Yes. So with this understanding, only most of the students have already started checking this, right? Yes. So if you observe here carefully, on this side, this is extra. So it is not an onto function. Okay. Similarly, here everything is satisfied equally. Hence, it is an onto function. When it comes to here on this side, everyone is matched to at least one. Hence, this is also onto function. Got it? Yes. So a function f mapping from A to B is said to be onto if and only if every element of B is mapped by at least one element of A. So every element of B should be mapped with at least one element of A. So that concept is nothing but onto. So A is greater than or equal to B. So here the concept is greater than or equal to. So the A elements, the number of elements in A should be greater than or equal to B. Got it? Yes. So for this, I cannot derive the formula, guys, because this is a standard formula. Okay. Yes. So for onto functions, number of onto functions possible will be, this is the formula, guys. So n power m minus nc1 into n minus 1 power m plus nc2 into n minus 2 whole power m plus and so on up to infinity. And remember one more thing, it is alternative, positive and negative, guys. Got it? Yes. So for easy understanding, I took the same example. Sorry, I took different example. Okay. So the number of elements in A is 4 and the number of elements in N is 3. So the first step is n power m. So that is 3 power 4, which is equals to 81 minus 3c1 into 3 minus 1 whole power 4 plus 3c2 into 3 minus 2 whole power 4. So even though if I continue, it will be 3 minus 3. So the result will be 0. So that is the reason why I have stopped there. Got it? Yes. So just by solving it, we got 36 as the result. Got it? Yes. So these are the onto functions if the number of elements are these. Okay. Okay. So now let us go through the next type of a function, which is a bijective function, guys. So to be clear, bijective functions are far more easier than onto and the other functions, 1-1 and onto functions. So what bijective function says that I don't know anything about, it will say like this. I don't know anything about everyone, but whatever elements are in X, whatever elements are in Y, they should be mapped to each other exactly once and everyone should be mapped. So indirectly it is forcing us to have equal number of elements in both. So any other case will be false and equal cases and each and every one should be mapped to other individually. Okay, yes. So is a function between the elements of two sets where each element of one set is paired with exactly one element of the other set. That's it. Okay, with that understanding you can say that indirectly n equal to m, right? Yes. Okay, so n is this side and m is this side. Remember. Okay, yes. So number of bijective functions will be n factorial because each and every guy. So here if you take this example, this guy will be 3, this guy will be 3, this guy will be 3. So sorry, this guy will be 3, this guy will be 2, this guy will be 1. So it is nothing but 3 factorial. If there are 100 elements, it is 100 factorial. In that way. Got it? Yes. So in this lecture, we have clearly discussed about the 3 different types of functions, guys. First, we started with 1-to-1, which is nothing but injection function or injective function, where one is mapping to the other. And similarly, next we discussed about onto or surjective function, where this guy is mapping to that guy indirectly. Similarly, the last topic which we discussed is bijective function, where the number of elements in both of the sets should be same. Okay, yes. So now I hope everyone got a clear idea about the concepts of function, right? Yes. So in the next lecture, we will be discussing the last topic, that is inverse of a function, guys. Okay. Okay, yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.